Okay, well, welcome to Lesson 7-6. I'm flying solo on this one, and thanks for tuning in this weekend. I hope everything went well in class. I'm sorry I wasn't there with you on Friday, but what we're going to be talking about today is we're going to be doing all of this solving stuff, but today, this lesson, and what we'll be practicing on Monday is we're going to be solving inequalities. Okay, so two-step inequalities. And we're going to use all the same tricks that we've seen so far in Chapter 7, but we're going to apply them to inequalities. So let's go ahead and get started, and let's look at some sample equations. Let's start with these three equations. Notice that each of these is an inequality. Oops, actually the last one isn't an inequality, but it needs to be. Let me fix that right now. All right, let's make this. Let's see, we've got greater than or equal to. We probably need a less than here. All right, so let's solve these, and the rules are going to be basically the same as what we've been doing. We're going to be doing SADMAP, opposites, and balance, plus any simplifying tricks that we've learned. Now, we won't start with those with these first equations, so let's just dig right in. Again, let's do them in blue. All right, so the first one, I have 5a minus 9 is greater than 11. So to solve an inequality, I solve it just like an equation. I want to get rid of the minus 9 first because SADMAP tells me to get rid of the subtraction first. So I add 9 here, right underneath the minus 9 so it can cancel, and I have to add 9 to the right side as well. Okay, make sure you always add to both sides, and normally it's to both sides of the equation. In this case, it's going to be both sides of the inequality sign. All right, we get a fruit ninja on the left. It'll leave us with 5a, and I did it, and that's a real easy mistake to make, to accidentally switch back to equals. So remember that you're doing an inequality. So 5a is greater than 11 plus 9, which is 20. Divide both sides by 5, and I get a is greater than 4. Okay. Now, the only real differences with inequalities are that we don't have an equal sign in the middle, and oftentimes at the end of an inequality problem, we can graph it. And you don't have to get really fancy about your graph. All you do is make a little number line, put the value, the number value that you have for your inequality, decide whether you have an open circle or a closed circle. If it's strictly greater than or strictly less than, it's open. If it's greater than or equal to, or less than or equal to. If it's equal to, then you fill it in. And a's, where are the a's that are bigger than 4? Well, those are all the numbers that are up here to the right. And the variable, of course, here is a. Okay, so that would be the graph of that, if they ask you to solve and graph it. The next inequality is negative 10 is greater than or equal to 1/2 x minus 6. Now this one's a little different because the variable's on the right side, but that doesn't change how we solve it. SADMAP once again tells me to get rid of the minus 6 first, and the way I do that is I do its opposite. I add 6 to both sides. On the left, I'm going to get negative 4 is greater than or equal to 1/2 x because the negative 6 and the 6 cancel out. Now, I want to get rid of 1/2 x. The way I get rid of that, I could divide by half, but we know that dividing by fractions is really better done by multiplying by reciprocals. That's what we're going to have to do at the end anyway. So we have to do that to this side as well. If I multiply both sides by 2 over 1, basically they're both over 1. So 2 over 1 times negative 4 over 1 is a negative 8. There's no sense to put the over 1. Is greater than or equal to. Here the 1/2 and the 2 over 1 cancel out, and I get x. Now, I can leave it like that, or I can rewrite this inequality. Notice that the x is where the point of the inequality is, so I could actually flip this around and write this as x is less than negative 8. These both say the exact same thing. So either you say the x's are smaller than negative 8, which is what the top one says, well, so does the bottom one. Once again, to graph this, we start at negative 8. This one is a closed circle because it's less than or equal to, or whichever way you look at it. And it's all the x's that are smaller than negative 8, so I shade this way. I personally like to always have the variable on the left because then the inequality sign will point the direction of the graph, the shaded arrow on the number line. Okay, they'll both point in the same direction. Okay, that's the big advantage of flipping around and having the variable always on the left. All right, one more. Go ahead. Why don't you pause me for a second and go ahead and do the last one on your own. It's 3x plus 4 is less than 16. Go ahead and use SADMAP, opposites, and balance, and solve this inequality and then graph it. Okay, as soon as you're done, resume the video, and we'll see if we get the same answer. All right, welcome back. I'm going to go ahead and switch colors just to remind you that this should have been done on your own. Okay, and what we're going to do first, SADMAP tells us to get rid of this positive 4, and I do that by subtracting 4 on both sides. Okay. Okay, go ahead and do that. This fruit ninjas out nicely. Plus 4, negative 4 cancels and leaves me with just 3x. This time my inequality is less than, and 16 minus 4 gives me 12. Finish this by getting rid of the times 3. You do that with division. You show that with a fraction on each side. So divide both sides by 3 and I get x is less than 4. And the graph for that should be a little tick mark on 4, an open circle because it's strictly less than, and this one is all the x's that are smaller than 4, so we're going to shade to the left. The variable for this one is x, so it should go right here, always on the right, even when we shade the other direction. I forgot the x right here, so I'll put the x there as well. Okay, so those are 3 inequalities, all two-step inequalities, all solved using SADMAP, opposites, and balance. So you might think there's absolutely no difference between solving an inequality compared to solving an equation. And for the most part, you're right, except for the fact that you don't have an equal sign. Okay, you have an inequality sign instead, and you have these graphs if you want to at the end. But there is one trick that we learned. One of the big differences when we're solving inequalities is when we multiply or we divide by negative numbers. Okay, so let me show you 2 more examples where that's going to come up. All right, and we'll just remember what happens. When you multiply or divide by a negative number on both sides of an inequality, you have to reverse the direction of the inequality. And we talked about this when we saw it the first time this year. If you think about it, if you know that 3 is less than 5, okay, because it's smaller, if you take both of those numbers and you negate them, and you look at negative 3 and negative 5, negative 5 is smaller. Even though the value is bigger, it's a more negative number. And anytime we switch from positive to negative, things kind of switch places. Suddenly being bigger makes you worse. Okay? So because of that, we always have to switch the direction of the inequality. All right, you'll see how that comes up in the next couple of problems. I'll do the first one for you, and then you can do the second one by yourself. And by that, I'm actually going to start with the one on the right, so you're going to do the one on the left. So let's go ahead and solve this one. I have 6 minus x is greater than 3. First, I'm going to get rid of the 6 is really considered like a positive 6, so I'm going to get rid of it with a minus 6 on both sides. Once I do that, this side will fruit ninja. I'm left with negative x. Don't lose that negative sign. That's the whole thing that's going to cause the problem for us. 3 minus 6 is negative 3. Okay? Now to get rid of a negative sign, the easiest thing you can do mathematically is multiply or divide by a negative 1. By multiplying by negative 1, you don't change anything. Same thing with dividing by negative 1. Okay? All it does is reverses the sign. So negative x divided by negative 1 is just plain x. And negative 3 divided by negative 1 is just plain 3. Okay? But the inequality sign has got to switch direction. So the answer to this one is x is less than 3, not greater than. Okay? And if you try some values, you can prove to yourself that this is true. Think of values that are less than 3 that would make the top green inequality correct. Well, pick something smaller than 3. Let's pick 2. If I do 6 minus 2, is that bigger than 3? Well, yeah, 6 minus 2 is equal to 4, and that is bigger than 3. If I put 0 in, is 6 minus 0 bigger than 3? Yes, because 6 minus 0 is just 6, and that's bigger than 3. Let's try the other direction. What if I put something in accidentally that's bigger than 3, like 4? Well, what would 6 minus 4 be then? Well, of course, it would be 2. And now it's not true. Okay, so if you put 4 in, it doesn't work. So whether we check something that's supposed to work and make sure it does, or something that's not supposed to work and make sure it doesn't, we can check that pretty quickly. All right, so as promised, I want you to go ahead and solve the next inequality. And remember the trick about multiplying and dividing by negatives, okay? All right, so go ahead and pause the video, finish this inequality, and when you're done, tune back in. Okay, welcome back. Once again, let's stick with the green. Just to remind you that this should have been done on your own. We're going to start with SADMAP, which tells us to get rid of the addition by 4. We get rid of that by subtracting 4 on both sides. If I'm really clever, I can even line the 4 right up with the 1's digits. So if my numbers aren't so easy, and it was an ugly decimal, this will set me up very nicely to do the subtraction. But in this case, it's pretty easy. 34 minus 4 is 30. Divide both sides by negative 2. Be very careful about the signs, all 3 parts. Negative 2m divided by negative 2 is just plain positive m because the negatives 2's cancel out. The less than or equal to is going to switch to greater than or equal to because I divided by a negative. And 30 divided by negative 2 is negative 15. So we get m is greater than or equal to negative 15. That's what you should have gotten, so double check, and that's what your work should look like. All right. Last but not least, everything that we have seen, like I've said at the beginning, from Chapter 7 is fair game with inequalities. So combining like terms might happen. Doing distributive property might happen. You might have variables on both sides of an inequality, in which case you have to start by getting them together. And again, I would do just like we did on Thursday night and Friday class. Pick on the little guy and move that variable. You don't have to do it that way. It just tends to work out better, especially with inequalities, because a lot of times when we pick on the little guy, we tend to avoid negative numbers times our variables. Okay, that helps us to not have to remember this whole reversing the inequality thing. All right, well, I'm going to sign off there. Again, we just hit 10 minutes. So thank you for watching. I hope you're having a great weekend, and I hope to see you back in class on Monday when we'll practice solving inequalities. Take care, everybody. See you on Monday.